our population is increasing, and our society with this increasing population requires energy. But we're going to head, now that we're done with climate change, we're going to go to a series of lectures that I'm going to entitle Hydrocarbons and the Energy Transition. I ran out of space, but it's the energy transition. And we're going to be here for a while. And what we're going to do is we're going to talk about something that's very important scientifically, it's important economically, it's part of the political conversation. It should be, because there are pros and cons to where we get our energy. And there is a conversation right now that is called global net zero. And what global net zero is in the face of population going through the roof and using huge amounts of energy to sustain the lifestyle and economy that we want, there is a push towards having a global net zero greenhouse gas emissions. So this would be an energy, so this would be zero greenhouse gas emissions. Currently, we're at a plus 59, right? So it's 59 plus or minus 7 gigatons of greenhouse gas emissions is what we're producing. Well, maybe it's half of that, because half of it actually gets absorbed by the natural system. So let's say that's like 30 gigatons. Well, the goal right now is to head down towards zero. And to do that, we have to diminish our reliance on hydrocarbons, oil, natural gas, and coal as our energy source. And so this is called the energy transition. Now, the energy transition today is a reduction. We can even just call it here low carbon energy, reducing our reliance on that. But there's been many other energy transitions throughout history. Let me just show you one, which I think is a good picture. Here is a change in our economy and our mobility, but also in energy, as we go from the horse-drawn buggy, where animals are our source of energy and plants that the animals eat, towards one that is more modern, right? Where oil is being combusted and in the form of gasoline, and we're driving cars. So that was a energy transition. There's been other energy transitions. We went from whale oil to kerosene for lighting lamps. And this was a huge change in the global economy and the ability of people to afford their lighting, because whales became decimated by overhunting, and we're just now rebounding from that. There was an energy transition during the Industrial Revolution from wood to coal. The impact of this is no better seen anywhere than in Britain, where forests were completely wiped out as Britain was trying to grow during the Industrial Revolution, and there's still many areas now that have no forests. But then Britain found coal, and they were able to become a leader because they had so much of this natural resource in their territory. So those are examples of energy transition, but the energy transition today is one heading towards a low carbon environment. The reason why this is such a transition is because here is where our energy comes from today. And if we look at this graph, you're gonna see, oh, this is a little blocked out, but gas, oil, and coal are significant, right? The majority, in fact, of where our energy comes from. Whereas a really nice big part, I'm kind of proud of it actually, this would be our low carbon energies currently. And the goal of the energy transition is to make more electricity from hydro, solar, wind, plus or minus nuclear. That's an interesting conversation. To reduce our reliance on these that produce greenhouse gases. All right, so there's the concept. But now let's actually talk about hydrocarbons, what they are and where they're from. Today we'll just get into coal, and then the general concept of a hydrocarbon. A general concept of a hydrocarbon is that it's a combustible CH compound. C, that's carbon, H, that's hydrogen, and it's a compound. And this CH compound is from dead organic matter. From dead organic matter. And within this definition, we can get a couple things. One, this idea of combustible means that is burnable and that it will reduce or release energy. The other aspect of this is dead organic matter, and this is where you get the word fossil fuel, because it is the fossilized remains of some ancient organism, not dinosaur people, not dinosaur. We think algae, ferns, plants, that kind of thing, that then is broken down and decayed into something that is just a chain of C's and H's, thus the hydro and the carbon. So in the textbook, hydrocarbons are talked about in section 16.2. This is the free online textbook. And of course, you can always go and search any term in Wikipedia, and it does a remarkable job teaching on this topic. The big three hydrocarbons are coal, oil, and natural gas. We'll talk about each of those in more detail right now. The difference between coal, oil, and natural gas has to do with the length of the CH chains or polymers. And the longer the chain, the more rigid the material. So coal is actually really long chains, and natural gas are the very short CH chains. Now, the way hydrocarbon is a fossil fuel is based on photosynthesis. And so here's my picture for photosynthesis, and we're going to do a chemical reaction here. In fact, we'll do this. We'll say photosynthesis is the reason for our energy. It's the reason for it being a fossil fuel. And the way photosynthesis works is that there is energy capture of light. When CO2 plus H2O plus light, which is our energy, it will react because of a plant's ability to do photosynthesis and make the hydrocarbon, which the basic plant fiber hydrocarbon, we're going to call it C6H12O6. And you can see here, C's are bonded with H's as a hydrocarbon, plus oxygen, plus H2O. And this isn't balanced, but we could balance it out if we wanted to. But that's not the purpose here. What I want to show you is that when photosynthesis is occurring, the reaction is going in this way, where light energy is being trapped. We could almost say that this right here is fossil solar energy. But then when a hydrocarbon is burned, the reaction goes in this direction, yeah? And so we're releasing that fossil solar energy from these bonds of the hydrocarbon. We're producing energy as well as greenhouse gases. All right, so that's the connection between hydrocarbons and photosynthesis. Now, to finish off today's lecture, I want to just go through the process of coal. And we'll save oil and natural gas for the next lecture. So we can do this as like number one, and it's coal. And the definition of coal is that it's a solid, and it's terrestrial plant material. Those are two key points. So this is a solid hydrocarbon. It's very long chains, and it is from terrestrial, that means land-bound, plant material. And this plant material dies and then gets buried in an oxygen-poor environment. Terrestrial plant material buried in oxygen-poor environment. The reason why oxygen-poor environment matters, this is something like a swamp or maybe like a river just dumps sediment across some plant material very, very quickly. This does not allow the breakdown to occur very quickly. There's number one. This is like the first part of the definition. There's a second part of the definition here. And what I want, the second part is that continued compaction purifies the coal. And what the compaction does is it drives away impurities. And the impurities in coal are things like sulfur. It's the actual H, the hydrogen in the hydrocarbon, and nitrogen, just kind of from the atmosphere. And what this does is we could say compaction drives away impurities, leaving behind a C-rich residue. This is the process of making coal. Burial is important in an oxygen environment, and then continued burial adds to this compaction, which then purifies the material. The steps to the evolution of coal, it's often talked about, we could almost do it this way. We have this plant material, and then plant material will first of all convert into peat. And what peat is, it's a brown, it actually still looks like a plant. In fact, let's just say that. Let's say that it looks like plant. And it's about 35% carbon when something is still peat. And when I say it looks like a plant, let me show you a picture of this. Here's a chunk of peat that was collected maybe from a peat mine where someone is being able to burn this for their source of energy, and you can see this still looks like soil and roots. Well, when peat gets buried and continues to be purified, it turns into a material called lignite. And lignite is low-grade coal. And this is soft. We're going to call it soft plus brown. Lignite is not worth very much, but it certainly can be burned as energy, and it's about 40% carbon. With continued burial and purification, lignite turns into the first real grade of coal, which is called bituminous coal. And bituminous coal is soft still, and it's black, but it's been purified significantly, and now it's up to about 70% carbon. And I'm going to put a dollar sign here because this is worth some money economically. The last grade of coal, the highest grade of coal, is anthracite coal. Anthracite coal. And this is big money. We'll put multiple dollar signs here because it is very rich in carbon. It burns clean, it burns hot. And when you find it, it is very shiny and black. It has gone through the most change and the most compaction. I'll show you a picture of each of these three so you can see what I'm talking about. So here in this picture on the left, this is a brown material. It's lignite. It has value. This is definitely at a mine, but the carbon content is low enough and the impurities are high enough that it pollutes quite a bit. Here is bituminous, starting to get a little shiny in places, but it's a dull black. And then over here, this shiny black, that is anthracite. Now, if you take anthracite coal and you continue to bury it and put it under higher temperatures and higher pressures, you'll get to graphite. And then eventually you can turn graphite into diamond. These are carbon, but we're just going to scratch them out. These are not hydrocarbons. They are not used in energy because they take more energy to burn than what they actually give out. Now, the final concept here within coal as hydrocarbons is I'd like you to know that coal occurs as a sedimentary rock. So here's a picture of coal, and I'm going to highlight, we're going to call these coal seams. And miners will chase coal seams as these horizontal layers, usually with strip mining. So we'll say mined by strip mining. Oh boy, I didn't say that, spell that very well. The other thing to say here is that coal is a sedimentary rock. All right, that's our study of coal, initial hydrocarbons, initial energy transition, and next class we're going to get into oil and natural gas.